Okay, chapter 16, autonomic. Autonomic, we might as well change it to automatic. Do we have control over it? No. Can we manipulate it? Yes, yes we can. Somatic nervous system. Soma operates under conscious control. We already talked about this. Controls skeletal muscle. What is the neurotransmitter that's secreted? Acetylcholine. I should hear everybody say this. Say it out loud. 1, 2, 3. Acetylcholine. Come on. Gee, many Christmas. You just had a 7-minute break. You should be like, woohoo, acetylcholine. Okay, that's better. Acetylcholine. Autonomic nervous system. Well, this is a whole bunch of craziness. Operates without conscious instruction. ANS, autonomic nervous system, controls visceral effectors, coordinated system functions, cardiovascular, respiratory, digestive, urinary. Wow, isn't that this entire chapter? Or I mean this quarter? So don't you think we need to actually put a little time and energy into this? We most certainly do. Organization of the ANS. Integrative centers for autonomic activity in the hypothalamus. Neurons comparable to upper motor neurons in the somatic nervous system. Now, I don't like all the abbreviations, but they're there. Okay? Visceral motor neurons in the brainstem and spinal cord are known as preganglionic neurons. Preganglionic fibers. Axons of preganglionic neurons leave the CNS and synapse on ganglionic neurons. So if I come over here to the board and we move our in and out of the way, does everybody remember this? This is the pre. This is the post. What is this right here? The synapse. That means that a neurotransmitter must cross this to the post. What were the two neurotransmitters that I said you needed to know for this chapter? Acetylcholine, epinephrine. So, what they're talking about is a pre and a post. And unbelievably, in the parasympathetic and sympathetic, the pre and post can either be long and then short, or the opposite, short or long. And on your guys' images that I told you needed to print up for this, it actually has them on there. The long and the short. It has them on those images. So by tomorrow, I would really like it if everybody in this classroom had those images that I talked to you about printed up. Parasympathetic, sympathetic, autonomic. Question?
Long and short. What?
The neuron. Yeah. So the pre-neuron can either be really super long or it can be really super short. The post-neuron can be really super short or really super long. It just depends if it is in the parasympathetic or the sympathetic divisions. So that will dictate what it will be. But in those, there are pre and post. And we actually narrow it down to where they come out, which is super cool also. So let's move forward. The images, you need the images. Why are the images so important? We're going to find out tomorrow. In fact, our lab that we're going to be doing will be a receptor lab, but I'll actually have a couple things for you guys about those images on our lab. So, here we go. Visceral motor neurons, autonomic ganglia, contain many ganglionic neurons. Okay, ganglionic neurons innervate visceral effectors, such as cardiac muscle, smooth muscle, glands, adipose tissue. Postganglionic fibers, axons of the ganglionic neurons. So, we actually innervate a pre and a post and end up on a visceral organ. We innervate a pre and a post and end up on a visceral organ. So, what were the nicknames? What was the nickname for sympathetic? Fight or flight. What was the nickname for parasympathetic? Rest and digest. They actually dually innervate. They connect together to all the visceral organs except for two. Let me say that one more time. Every visceral organ is dually innervated except for two. The sympathetic, unbelievably, gets to innervate two of them by itself. The sympathetic, fight or flight, gets to innervate two by itself. The first one, skin. The second one, the adrenal gland. Well, adrenal gland sounds like adrenaline. So what chemical do you think it might be secreting? Epinephrine. So those are the two that are innervated by sympathetic alone. Other than that, everything else is dually innervated. All right, so upper motor neurons, primary motor cortex, they come out, they're skeletal muscle. Okay, something that kind of a no-brainer. This is just skeletal muscle, which means it is not the autonomic, but the somatic. Thank you. How about this? Visceral organs. Autonomic. Somatic, skeletal muscle only. Autonomic, visceral organs. Autonomic nervous system operates largely outside our awareness, has two divisions. First division, sympathetic division. Increased alertness, metabolic rate, muscular activities. All right? And then it says parasympathetic division, reduced metabolic rate, promotes digestion. Let's just go to the simple names. Rest and digest, fight or flight. Okay? If we're speeding up one, then we have to slow down another. If you're running a marathon, what's going to be more active? Your heart or your stomach? So which one is actually being inhibited and which one's being stimulated? Sympathetic's being stimulated. Parasympathetic is being inhibited. Okay, so yeah, I haven't picked on you. This is perfect. Oh, yeah. Okay, you're sitting at home on your couch in your Snuggie with your tub of Ben and Jerry's. What's going to be stimulated? Your lungs? Or, let's say your duodenum. Ooh, that's a good one. Where's the duodenum? Anybody know where the duodenum is? Intestines. So intestines, small intestines, or your lungs? Which one? You're in your Snuggie. You're on the couch. You have ice cream. The duodenum. It's going to be stimulated. The lungs, well, you're kind of happy about you're like, ice cream, right? No, she is correct. The duodenum in the intestines is going to be stimulated. Your lungs, inhibited. You're going to be kicking it on your couch, enjoying your ice cream. I had fudge ice cream last night. Oh my gosh. With walnuts and whipped cream, extra chocolate.
I know.
So good. Okay, so if one is active, the other one is inactive. Now, there's only one exception to that rule. There's only one exception to that rule. Reproduction. Reproduction, that's the exception to the rule. Unbelievably, both the sympathetic and parasympathetic during reproduction, intercourse, they're both active. Dually innervated, and they're both active. One's not inhibited. Okay, they have different roles, and we'll find out what they are, but they're both active. So, sympathetic division kicks in during exertion, stress, emergency. It's called fight or flight. Parasympathetic division controlled during resting conditions. It's called rest and digest. This is all about pooping, peeing, laying on your couch in your Snuggie, eating ice cream. Not that you're doing all of those together in the Snuggie, because that'd be gross. But the idea is, it's about housekeeping. It's all about housekeeping. So show of hands, which one would you guys rather be? Would you rather be fight or flight? Show of hands. If you want to be fight or flight, show your hands. Or would you rather be rest and digest? Show of hands. Susan, I didn't see your hand, so are you confused? Which one would you rather be? You don't monitor the class, you raise your hands. Okay, so Susan, by herself, spotlight, blue, and Maria, because you didn't raise your hand either. What would you rather be? Fight or flight? You'd rather be fight or flight? Maria, you? Fight or flight? Okay. I'd rather be rest and digest. Why? Because, man, a backup of poop, that'd be horrible. But yeah, I want to clean the house. I want to make sure I'm good to go. I can be excited later. Think about dogs. When they poop, what do they do afterwards? They run all over and they get excited, and then they try to lick you. Weird. Susan's like, I don't get it. Housekeeping. Parasympathetic. Rest and digest. All right. Sympathetic and parasympathetic divisions. Most often these divisions have opposing effects. Okay? If the sympathetic division causes excitation, the parasympathetic causes inhibition. Two divisions may also work independently. Only one division innervates some structures. And I already told you those structures. Two divisions may work together, with each controlling one stage of a complex process, which I told you what that complex process is. Reproduction. Okay? So, sympathetic division. Preganglionic fibers, thoracic and superior lumbar, synapse in the ganglia near the spinal cord. The preganglionic fibers are short. The postganglionic fibers are long. So if we come over here to our list, we have a pre-short, post-long. Pre-short, post-long, so that makes this what? Sympathetic. That makes it sympathetic. Hey, guess what? That makes it sympathetic. Did you know that if it has a short pre and a long post, it's sympathetic? How about the fact that if you're in sympathetic division, your preganglion is short and your postganglion is long? So, golly, let's see here. Jessica, can you explain to me why I just said that 4 times for the new people in the class? It's going to be on the test. If I repeat something more than 3 times, it will be guaranteed to be on a test. Okay, so if this is sympathetic, this is para. Okay, if this is thoracolumbar, that means that this one is cranial sacral. That's where they come out. That is where that division's ganglia come out. So from right here to right here is sympathetic. Right here and sacral region is parasympathetic. It's where they come out. It's where they emerge. Okay? So, a long pre and a short post in the cranial sacral region is parasympathetic. A short pre and a long post in the thoracolumbar region is sympathetic. Any questions? By the way, just so you guys know, today's a test on your ability to endure long lectures. Okay? So, yes it is. Your sheets that you have, that you'll be printing up for tomorrow, have this on it. They have it on it in a way that's illustrated so well that every single thing that I'm talking about right now, when you print those up, you're going to be like, aha moment. Super excited. Okay? Go.
So do we fill those out? On
Nope,
our
they're
own?
already filled out.
Oh, okay.
They're already labeled.
Okay. What about the ones that we printed out yesterday?
Those will come later.
Okay.
Some of them are labeled, some of them are not. Yep.
Okay.
So, 7 responses to increased sympathetic activity. Well, heightened mental alertness, increased metabolic rate, reduced digestive and urinary functions. Now, some people say, why do people ink themselves when they get excited? That is a reflex inherent to that person. So if you've ever met a person that gets startled or anything like that, and they ink themselves, that's inherent to them. That's not on everybody, it's just on them, literally. Okay? So, energy reserves are activated. Well, we're talking about adipose and sugars that we need from the liver. Increased respiratory rate. Respiratory passageways are dilated. Let me walk over here for a second. What was the name of the chemical that dilated our bronchioles? Epinephrine. So when you're in fight or flight, your body's actually releasing epinephrine. So you can take big, giant panic breaths when that gigantic whatever is chasing you down the road.
What?
The idea is that when you're in fight or flight, when you're scared, when you're running, your body says, I have to do specific things. One of the things it's going to do is actually open up all your energy reserves. Then it's going to go ahead and activate the release of epinephrine, which causes your heart rate to increase. It causes your bronchioles to dilate so you can breathe. Fight or flight. Now, unless you're a fainting goat, okay, all this stuff's going to kick in. If you're a fainting goat, what do? Kaput. And it's done. And it's funny that Susan just did this. Increased heart rate, increased blood pressure. Remember, if you have more blood pumping through a vessel, you have increased pressure. Okay? Sweat glands are activated. So what were the 2 items I said that were innervated only by the sympathetic? The skin and the adrenal gland. Adrenal gland releases epinephrine, so that makes sense. And the skin is part of sweating. Go.
People who have like anxiety problems, is this just like overactive?
Not necessarily. Yeah, because not all of those are activated in anxiety. Hyperventilation might be, but not all of them are activated. I know people that are anxious that their heart rate's normal, but their blood pressure's through the roof. Parasympathetic division. Okay, so it has preganglionic fibers that are long, postganglionic fibers that are short. It emerges in the craniosacral region. It conserves energy. It conserves energy. It does housekeeping. And I'm not kidding. It actually does housekeeping. And here's something really cool to think about. If you were doing, let's say, a marathon or a long bicycle race, if you've ever done the STP, Seattle to Portland bike ride, you don't have to actually pee or poop or anything. Now, you might have to pee a little bit towards the middle of the ride, which is, it's 200 miles, so 100 miles into it. Okay, you might have to pee a little bit. That's because your body's getting rid of anything that's in the bladder. You're taking in fluids, but your body's burning them. Did you know that it takes almost a half a day for your parasympathetic to kick in so that housekeeping does what it's supposed to? It takes time for that amazing amount of energy to be shut off and then housekeeping to kick in. I've even met people that they say they don't go potty for like 2 days afterwards because of it. But also you have to think about, you're riding a bicycle for 200 miles. do you think you're gonna have a lot of energy stores off the food you're eating on that ride? No, not at all. Okay? So this is gonna conserve energy. It's gonna stimulate visceral activities. So digestion. Okay, 5 responses to increased parasympathetic activity. Well, decreased metabolic rate. Notice it says 5 responses to increased, ED, increased parasympathetic activity. So parasympathetic kicks in. These are the items that are going to respond to that. Decreased metabolic rate. Okay, decreased heart rate and blood pressure. Increased secretion of saliva and digestive juices. Increased motility, blood flow to the digestive tract, and then urination and defecation stimulation. All right? Now, we can manipulate these things. A nice cup of coffee in the morning is going to stimulate our what? Urination and defecation. You can say it at A&P. Don't be afraid of the words. Just when you walk out of here and the students are standing right there waiting to come in, just say defecation. Okay, just scare them. Scare them. They won't even want to come to class. Just scare them. Defecation. Okay, remember this is A&P. Get used to the words. You're going to have to use the words anyways. You're not going to be in the hospital and say, hey, patient in 4 pooped. Okay? No. So get used to the words. Defecation. Okay, pooping. This image is okay, but the one I have you guys print up for tomorrow is better. Way better. Okay? So this is an example of the sympathetic division, thoracolumbar, where it is going to. Thoracolumbar, short and long. Parasympathetic, long and short. Okay? Parasympathetic, which, I don't get this. Why is this so tiny and this gigantic? Weird. Okay? The one that you guys will be printing up is much clearer. It's well-defined. It's awesomeness. Okay? So, there we go. Okay, we come over to the parasympathetic. Pre is long. Notice how all the long ones coming out. Notice how long here, and then look at how tiny and short the posts are. Okay? So unfortunately, this image doesn't have a good example of it. In fact, it doesn't have an example of it at all. It does not have the skin, nor does it have the adrenal gland on there. Hence the reason why I put emphasis on this. The image you'll print up tomorrow, or tonight, it will. It'll have them on there. Okay? Enteric nervous system. Wow, okay, this is interesting because it's a third division of the ANS, and I'm not going to put a lot of time into it. Okay? It's an addition. It's a third division, extensive network in the digestive tract. Now, we're going to reference this, so for right now, just put it on a back burner, and we'll come back to it. It's better referenced when we get to the digestive system. Okay? So, but it's an extensive network in the digestive tract, complex visceral reflexes, roughly 1 million neurons. All neurotransmitters are found in the brain. Sympathetic division. Preganglionic neurons located between segments T1 and L2, which makes it what? Thoracolumbar. Why did we stop at L2? Someone explain that to me. That's where the adult spine ends. That's it. L2. Okay? What is that horse's tail thing called?
Echina.
You guys, okay. The equina, conus, what?
We have an idea.
Cana equina. Okay, there's actually several different names, but we're talking about the horse's tail. All right, so ganglionic neurons in the ganglia near the vertebral column, cell bodies in the preganglionic neurons in the lateral gray horn. Lateral gray horn. Just make sure we're right on track. Yes, we are. I'll get a clock in here tomorrow or the next day. Maybe I'll get like a Mickey Mouse clock. That'd be awesome. So much fun. Okay, axons enter ventral root of the segments. Okay, ganglionic neurons. We're talking about a ganglion. Okay, what is a ganglion? A collection of nerve cell bodies found in the, there you go. Sympathetic chain ganglia, collateral ganglia, and adrenal medulla. Go figure. They mention it, but they don't show it. Sympathetic chain ganglia in the body wall, inside the thoracic cavity, in the head and limbs. Where are they located? Well, right here. Postganglionic fibers shooting out here. Here's the chain ganglia. Sympathetic. So what's our pre? Short. Let's come over here. Here's the spinal cord. Here's our pre to the chain ganglia. From the chain ganglia, where do we have to go? All the way out to the visceral organ. So along post. Collateral ganglia, anterior to the vertebral bodies, contain ganglionic neurons that innervate tissues and organs in the abdominal pelvic cavity. Well, if we're coming out thoracic, lumbar, really? Abdominal pelvic cavity, everything right here. Okay, again, pre and posts. And then adrenal medulla. Very short axons. When stimulate, release neurotransmitters into the bloodstream. They do not synapse. Let me say that one more time. When stimulated, they release neurotransmitters right into the bloodstream. Okay, gentleman in the back with the hoodie. What's your name, sir?
Adam.
Adam?
Yeah.
All right, Adam. Like add in, like we're going to add you into the class, add in. I can deal with that, that's good. Okay? So when you're out driving your car, someone cuts you off, do you give them the one finger wave when they cut you off?
Yeah.
Yeah? He's like, I'm going to admit to it, I sure really do. Okay? Are you calm, like just all mellow, or are you jacked up? You're pretty calm? And you give them a one finger wave? What's up with that? Like, hi. Do you get amped up when someone cuts you off? Or maybe you got a close call? Or, hey, you know what? Maybe it's raining and you lost control of your vehicle for a second. You get pretty amped up, don't you? Does it go away really quick? Or does it hang out for a while? It doesn't really go away that quick. Okay, the reason why it doesn't go away that quick is because of this. When stimulated, it is released into the bloodstream. That means it circulates through Adam's complete body. And because it's in your body, it takes that much more time for it to get rid of it. If it was just a synapse, it'd be 1-to-1. Done deal. But it's not. It's, bless you. It's releasing it into your entire body. And the more it releases, the more amped up you are. The less it releases, the less amped up you are. Okay? So because it's in the bloodstream, it's long-lasting. Okay? It's going to be with you for a while. It's slow to activate, though. I mean, the startle response isn't, but it is because it's a second messenger. Do you guys remember second messengers? Yeah. A little bit slower to respond. Functions as hormones to affect target cells throughout the body. So, unbelievably, when Adam does release the epinephrine throughout his body, it doesn't say, I'm just going to go to your heart and cause your heart to increase in rate. It's actually going to go to everything, which means it'll have an effect on every single target organ it goes to. Blood pressure, respiratory system, cardiovascular. Everything will be affected by it. There's the adrenal medulla. Now, I want to point one thing out. It is saying adrenal medulla, not adrenal cortex. Let me say that one more time. It is saying adrenal medulla, not adrenal cortex. We do innervate the adrenal cortex. We do release a hormone from the adrenal cortex. That'll come when we get to the endocrine system. It's called adrenal corticotropic hormone. Adrenal corticotropic hormone. Okay, it's released from the adrenal cortex. We'll get to that later. So please make sure that you note that it's the adrenal medulla. Okay? Fibers in the sympathetic division, preganglionic fibers, are relatively short. Ganglia located near the spinal cord. Postganglionic fibers are relatively long, except at the adrenal medulla, because, well, it's the adrenal medulla. Organization of anatomy and anatomy of the sympathetic division. Well, we know that it is located in the thoracolumbar. That means T1 to L2. Gives rise to myelinated white rami, or ramus in this case, carry myelinated preganglionic fibers into sympathetic chain ganglia. May synapse at the collateral ganglia or in the adrenal medulla. Now let me stop right there for a second. The images that I'm going to have you guys print up tonight are actually going to stress this. They're going to stress myelination. Is it lightly myelinated or is it heavily myelinated? Okay? Are the pre-myelinated or the post-myelinated? So, again, I don't mind the fact that this is in the lecture and it's on the slides, but what you guys need is you need a good visual. You need to be able to lock this information in. When you print these images up, it's going to lock it in for you. I'll go over the images tomorrow, but for right now, I want you to focus on this, maybe highlight it, okay, put a circle around it. The myelination is extremely important. So, chain ganglia, preganglionic fibers, okay? Synapse on many ganglionic neurons. Fibers interconnect sympathetic chain ganglia. Each ganglion innervates particular part of the segment. Now, let's back up for a second. Next to every single elevator, there is what? A staircase. What can we do on the staircase? We can go up or we can go down. Can we go back over again? Yeah, we can go out to that floor. Right? If I go up the staircase, can I come out to the third floor? Yeah. So what is the elevator? The spinal cord. The ganglia that we're talking about are the staircase. We can go up, we can go down, or we can go straight out to the area we need to go to. Okay? Postganglionic fibers, paths of unmyelinated postganglionic fibers depend on its targets. Depends on where it's going. But notice that it's unmyelinated. So pre is myelinated, post is unmyelinated. Postganglionic fibers control visceral effectors, body wall, head, neck, limbs, enter the gray ramus, return to the spinal cord or spinal nerve for distribution. And then here's the big one. Postganglionic fibers innervate effectors, sweat glands of the skin, smooth muscle, and superficial blood vessels. So, Frank, why would we actually innervate the muscle around a blood vessel? Why would nerve fibers go to the muscle around the blood vessel? If someone knows this, just hold on, maybe raise your hand. I just want to see, this is just a refresher because this is something I've gone over. Do you remember why we would go to the muscle around it? Support, but what are we going to support with that blood vessel? Anybody want to help her out with this one? Nice and loud. Diameter. Do we want to dilate, supporting the blood flow, or do we want to constrict, reducing the blood flow? Or if you have high blood pressure, what do we want to do? We want to dilate to reduce the blood pressure. If you have low blood pressure, what do we want to do? To increase the blood pressure. Okay? So we're innervating these muscles to do just that. Dilate, constrict, dilate, constrict. Well, this isn't the sympathetic, so it's fight or flight. Where would we want our blood vessels to dilate if we want more blood in fight or flight? Unless you're one of those people that runs like this. That's weird. Right? Yeah, don't we want more blood to go to your legs? Yeah. Sympathetic nerves, postganglionic fibers, innervating structures in the thoracic cavity form bundles of sympathetic nerves. Okay? I think we'll stop right there. Do we feel like cookie dough right now? Big giant wads of cookie dough. Brains are completely flooded with information. Good. Because this will pretty much be the only time that we do a straight 2 hours of lecture. All right? So I wanted to make sure that we were up on our slides for chapter 16. So what are you guys going to do tonight?
Print.
Print. Please do not come to class without it. You need it. Okay, so print it up tonight. Bring it to class tomorrow. We will go over it tomorrow. Lab on Thursday. I always hold the lab in the latter part of the class period. And then Friday is what? Super quiz. Quest. All right, have a good day.